Alright, these last two problems from 4.5a, 67 and 69, these are a bit more challenging problems dealing with change of variables using U-substitution. Okay, so we rewrite our problem using rational exponents, and we see that the 2x minus 1 is inside parentheses, so we let that be the u value. Go through our derivative. Du over dx is equal to 2. Cross multiply, solve for dx, dx equals du over 2. So now we make our substitutions. Okay, x squared minus 1 doesn't get replaced initially, but we can replace 2x minus 1 with u, and then dx with du over 2. Okay, but we can't continue with the problem because this x squared needs to find a way to get rid of that x squared. So we look at our assigned value for u. So u is equal to 2x minus 1. Now if I solve for x, x is equal to u plus 1 divided by 2, right? Add 1 to both sides, divide by 2. So I can take this fraction and plug in for this x here. So now I have something a little bit messy. U plus 1 over 2 quantity squared minus 1 all over u to the 1/2 times du over 2. So if I can somehow expand this and combine with this denominator, my goal is to try to separate everything out as individual terms, and then from there I can go through the power rule. But we first need to expand this. So we have u plus 1 times u plus 1 becomes u squared plus 2u plus 1. The denominator 2 also gets squared, so we get 4. Now we have two fractions. It's going to be this fraction minus 1, so I have to find a common denominator, so I make that 4 over 4. And so I combine the numerator, which gives me u squared plus 2u minus 3 over 4. And I'm going to combine this denominator with this denominator space. So we have 4u to the 1/2 in the denominator times du over 2, and then this 2 can combine with this 4 in the denominator. So now we have something that we recognize a little bit more. Okay, one term in the denominator, so we can split this up into individual fractions. Once we have that, we can find a way to bring the u up to the top by subtracting exponents. So 2 minus 1/2 is 3/2. 1 minus 1/2 is 1/2. And this denominator, this variable we want to bring up to the top as u to the negative 1/2. So now we have something we can just simply use power rule. Okay, so we step through our rules, our power rule, resolve all the denominator, all the fractions by bringing them up to the numerator, and then finally replace u back in terms of x. Now 2x minus 1. Okay, 69 is also a bit challenging. So we look to see go through U-substitution. We see we let the u be x plus 1. We can replace both these values with u. So let u be x plus 1. Du over dx is 1, so dx equals du. We make our initial round of substitutions. Parentheses gets replaced with u, and then u plus x plus 1 gets replaced with u as well. I'm going to leave this in terms of square root, so u minus square root of u. Now this x needs to find we need to be able to replace this x here. It doesn't cancel out, so we look at our assigned relationship between x and u. So we can solve for x by subtracting 1 from both sides, so x equals u minus 1. So x gets replaced with u minus 1. Okay. Now we have to look for creative ways to cancel out and to simplify. So I can factor square root of u out, making it square root of u minus 1. And then the numerator, I can rewrite it as 1 minus u. And I can find a way to cancel this out by rewriting this as a difference of squares. So minus u can be represented as 1 minus square root of u times 1 plus square root of u, which will allow me to cancel out one of the parentheses. So now all I have is a negative parentheses 1 plus square root of u over square root of u. So now we can rewrite this as individual fractions, and we bring the u to the 1/2 to the top. Square root of u over square root of u is simply 1, and we go through power rule. So negative u to the 1/2 over 1/2. Integral of 1 is simply u. because u is now the variable, our independent variable. Simplify, and then replace our u values back in terms of x. So we have 2, negative 2 square root of x plus 1 minus x minus 1 plus c. Now this is a constant, so I can technically combine this constant with the plus c, and we can just merge that all as plus c.